Okay, a quadratic form. This is your general quadratic form. Okay? You have terms of degree 2 or less. Okay? X squared is of degree 2, obviously, right? X is degree 1, y squared is degree 2, y is degree 1, f is degree 0, xy is degree 2. Okay? Because x is of degree 1, y is of degree 1. If you multiply degree 1 by degree 1, you get degree 2. Okay? So whether that makes sense to you or not, it might be the first time you've seen that idea. It's really a pretty simple idea, right? If you accept that x and y are both of degree 1, and if you multiply two things, you multiply their degrees, okay? You add their degrees, I'm sorry. Because what is the exponents? Okay? That makes sense? We're not going to deal too much with this because this, if e's not 0, you have a rotated quadratic form, okay? You can easily rotate things with a rotation matrix, okay? But going to deal mainly with this situation where you don't have this xy term, okay? Now, if you've done rotation of conic sections, you know how that works, okay? But you probably haven't. I tried to teach in pre-calculus, and I gave up years ago. Okay, nobody ever understands it. In calculus, it probably should be taught, you guys had a really good calculus course, and some things are just so weird for people that they end up not getting taught. So you look it up, you know linear algebra, you know what rotations are, you can figure it out. Okay? Then we might, if we run into one, we'll go ahead and rotate it. It's not that bad. Okay, so anyhow, we have this. Now, so let's suppose you have a function of two variables. There it is. Okay? What's the graph of that thing going to look like? Well, I'll give you a hint. You better follow my hints. That's my hint. First hint. Okay? Confined to the xz plane. Now, if you confine the graph to the xz plane, what does that do to any of your variables here? And I've got equals 0 here, and that's not part of the function. This is the function. So we want to look at what this function can look like if we confine it to each of the coordinate planes. Okay? Gives us a good hint. Incidentally, no, I don't have to say that. Okay. Make sense? Okay, so if we confine to the xz plane, what's that tell us?
We're confined to the xz plane, we know the y.
The y is 0.
Yeah, y is 0.
And in the yz plane, x is 0. And in the xz plane, z is 0, right? That's xy plane. The xy plane, z is 0. Okay? So if z is 0, that means that this thing is equal to 0, right? Okay?
Would that make an ellipse?
And that's clearly, well, it could be an ellipse, but you don't know the signs of A and C.
So it could be a circle.
If A and C are equal, they
Could be an ellipse or hyperbola.
Like a circle.
Well, A and C could have opposite signs, right? Okay? So that, these things don't necessarily have to have the same sign. If they have opposite signs, then you're going to get this or this. Okay? And
This was another one also, I think.
if they have the same sign, then it'll be an ellipse. And of course, a circle is just an ellipse with no eccentricity, okay? So you also have the possibility that A and or C could be 0, which would give you a parabola. Or possibly just a set of planes, okay? So we'll see. But right now, let's just assume that A and C are non-zero and see what we get in the xz plane. Write out what the function would be in the xz plane. Write out what it would be in the yz plane. Write out what it would be in the xy plane.